In this video, we're going to be looking at weighting data with IBM SPSS statistics. Now, weighting data is a fairly common task that data analysts perform, particularly when they're interested in adjusting the data artificially to reduce sampling bias. And survey samples, of course, may not always perfectly represent the population from which they're drawn. And one might find, for example, that certain demographics, such as younger people or older people, are over or underrepresented within the survey sample. So applying weights can help us balance out the age distribution to match the population, and in doing so the weighting helps us make sure that the survey results are more applicable to the entire population. Another reason why people tend to use weighting is to increase or reduce the importance of certain cases. This is particularly true when we're doing things like modeling, such as using decision trees in SPSS, and this will allow the procedure, or will force the procedure, to pay more attention to certain records because they're of particular interest to the application that the person is working in. The third reason is to correct the data to meet certain statistical model assumptions. Weighting can allow us to adjust the proportion or the representation of the number of cases within a particular sample, and in doing so it adjusts the influence of certain data points so that we can better meet the statistical assumptions for the procedure that we're running. Let's take a look at our first example of weighting data by using the weight cases procedure within SPSS. So here in SPSS we have a data set already open. It's called employee, and it consists of 474 employees of a bank. And we have the variable here gender. If we right click on that and ask for descriptive statistics, we can see that the breakdown in terms of gender is 45.6% of the data set consists of female employees and 54.4% consists of male. Let's assume that in reality we happen to know in the population that this split should be 50-50. 50% should be females and 50% should be males. And we wish to weight the data so that it reflects those population proportions. How do we go about doing that? Well, depending on how we wanted to weight the data, we need to work out the ratio of female to male respondents or the ratio of male to female respondents. So for example, if we want to artificially increase the proportion of females, we're going to come up with a weighting where we divide the number of male respondents by the number of females, which is 258 divided by 216. That gives us a weighting value of 1.19444. That's how much we would be increasing the female sample by. Alternatively, we might want to reduce the number of males artificially in the data, and that would of course require us to divide the number of females by the number of males, which is 216 divided by 258, which gives us a proportion of 0.83721, which is how much we'd be reducing the number of males. Let's look at both examples and how we compute these weighting values in SPSS statistics. So we're going to start this process of creating a weighting field, and we're going to do that by going to transform and clicking on compute variable, and I'm going to create a field in here and putting it in the target variable box and calling the field weight1, and it's simply equal to the value of 1. This is our default value. In other words, if we were to weight the data by this value of 1, where every single case is given the value of 1, it wouldn't change the proportions in any way. It'd be exactly the same as not applying a weighting variable to it, because we're not increasing or decreasing the representation of individual records within the data set. If I rerun this procedure, however, if I go back to it and do it again, I can change this so that it now reflects the proportion for the female respondents, the proportion that we want to artificially increase them by simply changing that to 1.19444, and I'm going to make sure that it only applies to the female respondents by clicking on the if button and saying include if the case satisfies the following condition, and the condition here is that gender equals female. Well, what's the code for female? If I right click here, you can see that the code for female is F. This is actually a string field, so because it's a string field I need to put the quote, the character in single quotes. So it's quote F, quote, and click continue. If I click OK at that point, it says, do you want to change the existing variable? I say yes. And now we can see that the field has been updated and the value 1 has been changed to 1.19. In fact, I can just increase the decimal places here so you can see that it is actually 1.19444. And that only applies to the females. So the males are still have a value of 1. And that means that when I use this as a weighting field, only the female records will be affected by it, and their proportion will be artificially increased by a factor of 1.19444. To apply the weighting variable, we simply go to Data, and we click on Weight Cases. You can see that the Weight Cases procedure only allows for one field to be added in here, so I'm going to add in Weight 1. Click OK at that point. And as we return to the data editor, it doesn't look like anything's changed, except for the fact that there's this very subtle message saying weight on has been applied. And if I right click on the gender variable here and ask for descriptive statistics, we can see that now we have 258 females and 258 males, and the proportions are 50-50. In fact, all of the variables are affected here. The same thing would happen if we looked at the job cut variable. Now it looks like we had 516 cases, when in fact, we definitely didn't have that originally. We can see that back in the data, that's an artificial factor, because if we look at the bottom here, we can see there actually are 474 cases. So that weighting has been applied, and we've artificially increased the proportion of females in the sample. What if we wanted to do the opposite? What if we wanted to be more conservative and actually just go in the opposite direction and reduce the number of males in the sample? Well, to do that, we simply create a new weighting field. We go to Transform Compute Variable, and we call it Weight 2. And this time I'm going to say include all cases, and say once again it's equal to 1. If we click on that, we can see that it's equal to 1. There's weight 2, same as before, and we go back to Transform Compute Variable. And we say, okay, now it's not equal to 1, it's going to be equal to 0.83721. And this is only going to be applied to the male gender. So we're going to say where gender equals M, quote unquote. Click OK. It says, do you want to change existing variable? We say yes. We'll just increase the decimal places so you can see the values here. Here we have the values. And now I'm going to weight the data instead by the weight 2 value. This is potentially a more conservative way to do it, because we're not artificially increasing, we're actually weighting down the data. So depending on how many cases you have to begin with, you might want to adopt this more conservative approach. I'm going weight 2. And now if I ask for a frequency table of gender, you can see again we have 50-50, but this time it looks like we've got fewer cases. It has weighted down the number of males from originally 258 down to 216. So we've weighted the data so we have equal proportions. And that's an example of using the weight cases procedure and how we create a variable to weight the data by, to switch it off, to go back to the original not unweighted data. We simply click do not weight cases, click OK, and we're back to the unweighted data. The next method we're going to look at is using the rake weights procedure. Rake weighting is available if you have the SPSS Advanced Statistics module installed. Unfortunately, if you don't have that module installed, you won't be able to use this method. It's actually based on a Python extension that ships with SPSS. Python extensions can also be manually searched for and added using the extension hub, which you can access within SPSS Statistics. One of the advantages of using it is that there's no need to use the compute procedure to create a weighting variable as we did earlier. But its main advantage is that it can be used to weight data based on multiple variables with different weightings, and it reconciles these different weightings into a single weighting variable. Let's take a look. So here we are back in SPSS, and if we want to access the rake weights procedure, you'll find it under the data menu here. It's labeled rake weights. You see it's got this little square blue symbol next to it with the cross in the middle, indicating that it's an extension. In this case, it ships with the software, so it should be present if you've already got the Advanced Statistics module installed, which we do have. And if I click on this and open it up, you'll see that it's actually only showing two fields. It's only showing two categorical fields here. It's not showing the gender field, and that's because although the gender field is a categorical field, it's a string field and it can't work with string fields. So before I do anything else, I'm going to create a numeric version of the gender variable by going to transform and then down to automatic recode, choosing gender and asking it to create a new field called gender underscore num, indicating that it's numeric. Click OK at that point. And here we have our numeric version of gender using automatic recode. Notice that now, instead of codes M and F, it has code 2 for male and code 1 for female. So if I wanted to recreate what I did earlier and balance out the data so that we had a 50-50 split across gender, not 45-55 or thereabouts, we could do this by using the rake weights procedure by going to data and down to rake weights. And the first thing I do is I specify a name for the weighting field. So just to make it absolutely clear that it is a rake weighting procedure that's creating, I'm going to call it rake weight. Then I tell it what variable I want to base my weighting on, which in this case happens to be the variable gender. And then I simply tell it, what categories have what proportional split across them. Well, we've got category 1 and category 2 here, and I want the data for category 1. I want half of the data to be in that category, so I'm going to make that 1 0.5 or 0.5, it works the same way, and 2 for the males 0.5. So I'm basically requesting a 50-50 split. So you specify the category number and then the proportionate split. It doesn't actually have to add the 100%. It will deal with that itself, but in this case obviously it's going to add the 100%. If I click OK in this case, you can see it immediately creates a weighting field for us. It's rake weight as we've named it here. The weighting has been applied, weight on appears, and if I right click and ask it to do some descriptive statistics, it shows that we get a perfect 50-50 split, along with a little report up here when we run the rake weights procedure, showing us the before and after of how the weights have been applied. But you can see that it's 50-50, so it's 237 records in each category of gender here, still totaling to 474 records. Okay, let's say we wanted to take things a little bit further and we wanted to look at another variable and weight the data by another variable and to change the proportional representations in that variable. Well, if I'm going to run the rake weights procedure again, I can't have a rake weight already existing and I can't have the weight on, so I'm just going to delete this one, and as soon as I do so, the weight on message disappears from down here in the status bar. Let's have a look at this variable here, jobcat. Let's say for whatever reason here I wanted to increase the proportion of custodial workers and maybe increase the proportion of managers. Well, maybe to do this I could have the split instead of 76.6 and 5.7 and 17.7. maybe I could have 70%, 10% and 20%. So that would mean that the splits within the rake weights for this group, this first group here, would be 0.7, then 0.1, and then 0.2. And let's run that. So we'll go back to the rake weights to control totals, and we're going to pick up the employment category. Now we're adding in a second control variable. Remember, we've still got gender specified in here, and 1 is the clerical variable. I'm going to make that 0.7. 2 is the custodial group, so the just custodial category. I'm going to make that 0.1, and the third group is the managerial category. I'm going to make that 0.2. If I click OK at that point, the rake weights variable is recreated again, and if we look at the variable gender, we see that it's still 50-50, so it's still weighting by gender. And if we look at the variable jobcat, we can see that this is now split to 70, 10% and 20%. So we've still reconciled it to 474 cases. So it's weighting the data by both variables at the same time, which is quite powerful way for us to create a weighting field. Something that's well worth pointing out here is that you can actually call up this procedure again, and let me just delete the rake weights here. I'm going to run it again, I just want to point out you could actually change the population totals. You could say, actually, I want to just round everything up to 500 cases instead of 474 cases. Click OK at that point. Now look at the variable gender. It's still 50-50, but there's 250 cases in each one. And looking at the variable job category, again, we have 500 cases, but it's still keeping the proportional split 70, 10, and 20%. And that's using the rake weights procedure in SPSS.